Hello everyone. In this video, we would be discussing September 2022 CS2 B IFoA paper. The solutions are true and to the best of my knowledge. If you all do not find anything correct or not matching to the examiner's report, once the answer is there, you all can comment it into the comment section. But yes, these are to the best of my knowledge. Starting with the paper, first question is of time series. Before answering this question, the following R code should be run. So just copy this code and put it into R. This will run the entire code for you over here. First thing, we can run this entire code together into R. Then comment briefly in your own words on each line of R code above. So we can see that set.seed is used for the seed, setting the seed value or for random number generation. Then ARIMA, why is a time series, a stationary time series generated from ARIMA.sim function, which is an MA series of order 1. Okay, and of size 400. And ARIMA function is then used to fit an AR1 series to the model. Okay, then we have the standard error of AR1 process is 0.0024, which is given over here. Once you run fit over here, if you see the standard error is this, then we have been said the state the standard error. So we have stated the standard error. Determine the corresponding 95% confidence interval. So 95% confidence interval is given by C of A minus 1.96 into 0.0024, comma A plus 1.96 into 0.0024. So we can store it and we can get the confidence interval for these. Comment on your answer to part 2. The confidence interval determined contains a value of AR1. So it is okay. It is inside the interval. Then calculate the predicted values using the model fit the future values of y for 10 steps ahead. So we can use this predicted value. Predicted value for 10 steps ahead. Okay. And then we can store the standard error and predicted values. They have then asked us generate display in your answer script a matrix of A of dimension 10 into 2, which contains the predicted values in part 4 together with the corresponding standard error. So we created a matrix with predicted and standard error values with 10 into 2 columns and rows. And we have just generated with the column names as well. Okay. So we can see the matrix. It's like this. Then, because I've told you to display, construct R code to generate a plot that contains the time series Y together with 10 steps ahead predictions and the 95% confidence intervals. So first, calculating the confidence intervals, predicted minus 1.96 into standard error will calculate my confidence interval, lower confidence interval, then upper confidence interval, and I can bind them into a matrix. Though as such not required, you can just plot. So plotting the time series, this is the original time series Y, then we can just create a lines over it for the additional 10 steps. Okay. Then we can create a line of lower CI. If you see, this has come, and then the line of upper CI, which has come over here. Okay. Then construct a R code to plot a generator plot that contains a time series data Y together with 10 that this we have done, sorry. Construct R code to display sample next to each other the ACF and sample PACF. So we create par MF row, then we create an ACF, and then we can create a PACF for these two. Then comment on the graphical outputs of 6 and 7. So from 6 and 7, both we can see. So if you see, construct R code to display next to each other the sample ACF and PACF with residuals of model of it. Here we can see that the time series is stationary and PACF starts with a lag of 1. Okay. This is stationary time. The time series is not stationary. We need to convert it. We need to difference it once. And once we fit the new one, ACF of fit of residuals, and the fitted ACF shows that this is an MA1 series with lag 1 after it is cutting off, and fitted PACF shows that it is all under the within the confidence interval. So it's a good fit. So after the fit, it is a very good fit to the model. Okay. And from here also we can see that sorry, so from the PACF we could have seen that it's a AR1 series, and the fit ACF also show fitted ACF also showed it's a very good fit, and PACF also is all lying within the interval, so it's a very good fit. Again, just clearing the plot and drawing all from beginning. So these were the sorry, these were the two we had drawn earlier, and these are the two we drew later. And then we have we have and perform the junk box test for the residuals of the model fit with 4, 6, and 12 flags. So lag 1 is box or text with lag 4, then 6, and then 12. So all these three lags can be seen. You can just display the three lag. Lag 1 is basically p-value with 0.16, which is greater than 0.05. Then we have 0.23, which is again greater than 0.05, and this is again greater than 0.05. So from all the three, we can see that the values of greater than 0.05 at 5% level, we cannot reject H naught. We do not have sufficient evidence to reject H naught. Hence means the residuals are a good fit to the data. Okay, this was the first question, very direct, 30 marks. Then before answering this question, the survival packages should be loaded into R with the following code: install.packages survival and library survival. The government of country U has asked non-profit organizations to study possible adverse effects of a new vaccine administered to individuals with particular reference to the possibility of blood clots within the first 28 days of receipt of a vaccine. Before answering this question, the CS2 B question file should be loaded into R and assigned to a data frame called data. The .csv file contains data from investigation for 2,400 individuals. The file contains the following 6 variables: live patient identifier 1 to 2,400, drug indicator 1, 0, age indicator 0 to 1, and comorbidity indicator 1, 0. And status time. All this is given. Comment on whether censoring is investigation is likely to be non-informative. According to me, it is not likely to be non-informative because all the period of censoring has already been given, though the reason of censoring here is sensed to be unknown. Censoring due to death and the reason of death is unknown. It might be possible that due to this unknown reason, we can say that it's non-informative. Otherwise, all periods of censoring, since it's known, and all the admission to hospital reasons other than blood clots are also given. So it is likely to be it's not non-informative. Okay. Construct a data table named data main, which is same as data, but with a new column added. The new column added should be named ST and should contain the value 0 if status in the data is 0, 1, or 3, and 1 if it is 2. So we have this set WD, we load the data. Then data main is same as data, but with an extra column. So we create an extra column which says, if else status is 0, 1, 3, then it give me 0. Otherwise, if it is 2, then give me 1. Okay, and they've asked you, display the last 20 rows of data main. So tail of data main, comma 20. Then plot the Kaplan-Meier survival functions required to analyze the effect of vaccination, assuming that censoring is non-informative. You should plot both survival functions on the same axis as using separate colors to identify, using a range of 0.97 to 1 on the y-axis. So you've done a fit of KM, survival data main $time $ST, follows data $main $drug, confidence type is equals to plain. Okay, and then we calculate summary of fit KM, which is shows us the for 0 and which shows us for 1. Then we have again, since my par MF row was not correct, so I've just changed it. And plot fit KM. Just drawing plot fit KM, Y limit is set to 0.97. I've taken colors to be red and blue. So make sure red and blue you write not vaccinated and vaccinated, where 0 shows not vaccinated and 1 shows vaccinated. Okay, so yes, all these are plotted on the same axis. Okay, then you have been told, comment on your plot from part 3. So we can see that for not vaccinated people, as the time increases, the morbidity falls, but they do survive for a greater time. Okay. They do survive for a greater time, but the probability of survival is obviously less. Although the probability of survival for is higher for people with not vaccinated. Those who are not vaccinated, the probability of survival is higher. Okay. Then we have next is analysts in the organization have decided to analyze further by using cost proportional hazard model by adding covariates into the investigation. Significance of covariates, at least two covariates and two covariates to be compulsorily used as vaccine indicator and age. They are now deciding to add one more covariate, comorbidity. Test the hypothesis using the likelihood ratio test. The comorbidity has no effect on blood clots, allowing for vaccine indicator, stating the null hypothesis, alternative hypothesis, and using the Breslow method for tie handling. So we'll just do a fit of one with Cox pH with data time. Time and ST follows drug into age. So vaccine indicator is there and age is obviously also there. And ties is equals to Breslow. Okay. This is fit one. And then we have next we have added comorbidity into this model. Data main dollar comorbidity. You can just add it or you can use it as a extra interactive variable, multiplying it through all the three as interactive. Any of the two works. Okay, or any of here also you can add a plus sign instead of using having an interactive variable. So we have fit 2 as well. And then we have LF is for the likelihood of fit 1 and LT is likelihood of fit 2. Then we do a likelihood test between the two variables, minus of 2 into LF minus LT. Then we have a test statistic. I think LF did not get stored. Sorry. I'll just run these together. This is okay. LF is fit $1 log likelihood, LT is fit $2 and TS is this. And test statistic I'm getting is 13.70. Now we can check the upper 5%, upper tail of the distribution, the upper tail of this test statistic. 1 minus p chi SQ of 13.7, 1. Because we have added only one extra variable. So which is 0.002, which is much less than 0.05. So we have sufficient evidence to reject H naught. Hence, the model with comorbidity is a better fit to the model than the one with only vaccine and age. Okay. Last, we have question 3, which is from machine learning. Again, our data has been told to import. So let's import this data set. Okay. Then we have X. Okay, then we have X. First, they have told us that this data set has 4 columns, MPG, DISP, QSEC, and HP. You're asked to build a regression model to explain the response variable HP in terms of the features of MPG, display, and QSEC. Thus, the model must be in the form yi is equals to beta 0 plus beta 1 into MPG plus beta 2 into DISP plus beta 3 into QSEC plus epsilon, where beta naught, beta 1, beta 2, and beta 3 are the regression parameters and epsilon the error term. This model can be written compactly as y is equals to x beta plus epsilon, where y is the vector containing the response data and x is the design matrix. Write R code to load the data set CS2 B question data and create the design matrix X, including column headings, and display the first 6 rows. So we have imported the data set. I need MPG, DISP, and QSEC in my matrix. So I'll just do those and then I'll create column names for those. Okay. So you'll see I get this entire matrix. First 6 rows have been set. So you can just display head of X as well. Okay. Then Y is the matrix which is required for the response variable. Okay. Which is HP. Okay. Now we have, if you want to create the model, but it's not required. Now they have told us ridge regression. Ridge fit is basically, they've told us write a function it told us that you would like to fit the above model by minimizing the following. It can be shown that for this value of lambda, the estimated that meter and expression has been given. Okay, where I is the identity matrix and X transpose is state the name of this modeling approach. This is the ridge approach. Now, why is this a ridge approach and not the lasso regression? Because this is a squared approach and ridge regression deals with squared approaches and not lasso. Lasso only deals with absolute. Construct an R function ridge fit that takes an input value of lambda, the vector response of data, and the design matrix, and then returns the values of beta lambda and this. So we have to construct a ridge function. So ridge fit is a function of lambda. They have told its input should be lambda, the response variable, and the design matrix. Beta lambda, then we have, we have a expression called, we have to return the value of this. So this -1 inverse is used using solve. So solve, then transpose of A, percentage matrix percentage, which is A plus lambda into diagonal of 3. Now lambda is not a matrix, so we can avoid using the lambda matrix multiplication here. Again, matrix multiplied, transpose of A, whatever matrix we give, and again matrix multiplied with the response variable y, and we have to display this. Okay, so this is the function which is created. Then they've asked us to test it for the value, calculate the display value of vector beta 2 where the value of lambda is equal to 2, and we have the input variable design matrix and the output variable as well. So P is the transpose, and why am I taking a transpose of this? Because I want to displace it into a row instead of a column. Okay, so this will give me the value of P. So if you see, P gives me MPG, DISP, and QSEC. This values of a ridge fit for the values of lambda. Okay. Now construct an R code to compute the values of vector beta lambda and store them into successive rows of matrix. Name matrix lambda for lambda is equals to I by 10, where I is equal to 0 to 10,000. So now we have to do the same function for 10,000 for 10,000 one times. Basically 0 to 10,000 means 10,000 one times. So matrix lambda is one which you'll create. Then you'll create I from 0 to 10,000. Lambda is nothing but I by 10. We'll use the same ridge fit function lambda, what we have created above, only with a loop for j in 1 to length of I. And now lambda will take values one by one, lambda of j, and everything else remains the same. Okay, and matrix lambda, R bind of matrix lambda, comma T beta lambda. This will just keep on adding rows to my matrix. Okay, this is basically what you write. Ridge fit function lambda y, j beta lambda, whatever function, and this diagonal of 3 has come because once you multiply the 32 into 3 with 3 into 32, 3 into 32 with 32 into 3 over here, transpose of A in this, then you get 3 into 3. So here we have directed it in 3 because otherwise it would be a difficult and complex function, and we got this. Now we can display the result. We can take the input of result lambda, and then we can take y as the response and x as the, and we can store our answers in result. And head of result will get those different values of MPG display in QSEC. Okay. Display the top 6 rows. This is done. Okay, then we have, you would like to select the best value of lambda. A senior statistician suggests that you should base your selection on statistical information criteria. What is the criteria? That effective dimension of the model. For this task, it can be shown that effective dimension is the sum of the diagonal elements. Okay. Now, this is the matrix which has been given to us. Sum of the diagonal elements of this matrix. Construct an R function called dimfit that takes as input the design matrix and the value of lambda, and then returns a corresponding effective dimension. So this is the lambda it takes, and we'll create again dimfit is a function of A and lambda, where di will be just as I'm converting this to a table so that the diagonal elements can be added, and per A percentage solve. Again, you just have to see this and write this entire thing. Matrix multiplication inverse is solved, and then again matrix multiplication and transpose. Effective will store the sum of diagonals, and then we'll display the effective. Just that this is a function. So we run this function. and we can check this function for a input matrix, and our lambda is equals to 2. We are getting an answer which is effectively close through 3. Now, when there are so many lambdas where I is equal to 0 to 1000 and lambda is I by 10, then how do we do this? Again, same thing we need to do is we need to create a vector. Now it's only a vector which is of 10,001. Dimfit, same function remains, only we'll add a loop that for j in 1 to length of I, the lambda will take values of j and will run this same thing, and vector dim will store each of the values of effective. Okay. And then you can run this entire code. Okay, and then result will be once you put x and L lambda, and then you can plot. Since they've asked you to plot, comment on your plot. It's a flat line because almost all values are close to 2. So you can see the last value is only different. Otherwise, all values are very close to 2. That is why we got this answer. Okay. That means the dimension is the effective dimension of this matrix is always 2 for all types of value we give to this answer. The last question had no such knowledge of chapter which you would require. It is basically the knowledge of R which you require. You should know functions and you should loops. And it's every time that IFoA gives such a question in CS2 paper where you do not require knowledge of R much, but you require knowledge of your, I would say, the basic R concepts. That's it for the paper. Thank you so much.